Good afternoon, everyone. Okay, so we the last section of the last module in the last week of the course. Wow, we are just about done with all the material that you need to learn from Calculus 2. All right, so this section is on Taylor and Maclaurin series, and it picks up from us learning about power series in the last two sections. So in Taylor and Maclaurin series, we are going to describe the procedure for finding a Taylor polynomial of a or a function, explain the meaning and significance of the Taylor's theorem with remainder. And I don't think we're going to get to actually doing the remainder of the Taylor series because with time and we need to prepare for our final. Okay. So what is a Taylor series? So we want to start with the function f of x, and it is continuously differentiable at a point x equals a. A could be anything. A could be pi, a could be 1, a could 1.7. Normally you don't pick anything like that. And then what you do is you're able to write the function f of x as the sum n equals 0 to infinity of the nth derivative of the function evaluated at a over n factorial times x minus a to the n. And this is called the Taylor series expansion of the function f of x about the point x equals a. Okay, so you have some value a that goes in there. So actually, how about, no, I'm going to leave it just like it is. And here's a special note that if by chance a happens to be 0, so if you do your series about x equals, and it's about a equal to 0, like that a, then it's called the Maclaurin series. So we have this function f, whatever it is, that, and we're going to choose several. And then we're going to need to take several derivatives of the function and then get a formula to be able to create the Taylor series. Okay, so what I have, so let's start off with an example. So the first example is if the function cosine x. So this happens to be its Taylor series. We can say Maclaurin series because here a is equal to 0. Okay. And so a is equal to 0. So this is the Taylor series for cosine x. So the cosine of x is the sum n equals 0 to infinity of minus 1 to the n plus 1, 2n plus 1 factorial, x to the 2n plus 1. And if you were to sum this thing up all the way to infinity, you would get cosine of whatever value you want. Okay, so that's the Taylor series, actually the Maclaurin series for the cosine. Then I want to do the Maclaurin series for the sine. So the Maclaurin series for the sine looks a little bit different. It's minus 1 to the n, x to the, something is wrong. When n is, now wait a minute. Why am I confused? The cosine of 0 these are backwards. These are backwards. Now they are correct. Okay. So what does this act, what do these look like? Well, let's write them out. So the sine of x so when x is 0, when n is 0, I just get x. Then the next term is going to be negative because it's going to be n equals 1. This is going to be x cubed over 3 factorial. The next one will be x to the 5th over 5 factorial. Then we will subtract off x to the 7th over 7 factorial plus ... Okay, so that is the Maclaurin series for the sine of x. So let's look at the one for cosine. So cosine of x, when n is 0, I get 1. Then I'm going to get minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus ... Okay, so these two I am giving to you right now, all right? I haven't yet shown you how to solve for them, and that is what we're going to do next. So most books, I'm pretty sure most books derive these. Your textbook does as well. I'm not going to ask you to derive these. Their formulas are somewhat difficult to figure out. But we are going to do an easy one. And then a more challenging one. Okay, so this one, we now want to derive the Taylor series expansion for the function f of x equal to e to the x about a equals 0. Okay, so how do we do this? All right, so I already have written, you guys can you can create a chart just like that. I'll give you a few moments to create a chart. All right, and then I'm going to explain to you why we create this chart in order to be able to figure out what our series expansion is. So please go ahead and make this chart. Okay, so now we're going to derive our very first Taylor series, and this is one of the easiest ones because the formula is the easiest. All right, so make a very simple chart or table that gives you n, the nth derivative, and the nth derivative evaluated at our a. So for us, our a is 0. So that is what we are going to do. Basically, we really are doing a Maclaurin series since this is about a equals 0. Okay, so the 0th derivative means I haven't taken a derivative, so that's just the function. Okay, the first derivative, what is the first derivative of e to the x?
Isn't it e to the x?
E to the x. What's the second derivative of e to the x? I know it's a dumb question. And the third derivative of e to the x. The fourth derivative of e to the x. And if I kept doing this, the nth derivative of e to the x is e to the x. Actually, I think I am going to add a column. Okay, so now that we've done that, which I have a feeling I'm getting ready to have to redo it, but that's okay. What I need to now compute here this needs to be a fraction. And this is going to be the nth derivative divided by. So I figured I would have to rewrite it because they would all be scrunched up, but that's okay. You know, all of these were e to the x.
Excuse me.
Yes.
I know you just said something about it, but will you send, I guess, the link to do the test?
Oh, it was on Blackboard. I posted on Blackboard that you were supposed to send me an email to let me know you wanted to retake an exam.
I can still do that.
I'm going to let you guys have one more day.
Appreciate it.
You're welcome, because once I go in and say which people can take the exam, it's really a pain to go back in and redo it. So you have till today to let me know if you want to take an exam over, but you got to tell me you can take your lowest exam or a missed exam. Okay. All right. So we said all of these were e to the x. And the nth derivative was e to the x. Okay, so now what I need to do is evaluate that function at 0. Well, e to the 0 is 1. This e to the 0 is 1. E to the 0 is 1. E to the 0 is 1. This one is a very easy one. E to the 0 is 1. And then the nth derivative at 0 is going to be 1. Okay, so I need the nth derivative at 0 over n factorial. So over, this will be 0 factorial is 1. 1 factorial is 1. This is going to be 2 factorial. This will be 3. Oh, sorry, I'm being silly here. I need 1 over 2 factorial. And I need 1 over 3 factorial here. And I need 1 over 4 factorial here. And I can guess that this will be 1 over n factorial just by my formula. Okay, so any questions about how I did that? I made a table. All right, I took n going from 0, and just a good enough number till I figure out the pattern. The nth derivative I found, then I evaluated the nth derivative at my a. And then I found my nth derivative at my a divided by n factorial. Okay, so now let's plug it in. So we said above that f of x, my formula, is the sum n equals 0 to infinity of the nth derivative at whatever a I was looking at over x minus a, oh, I'm sorry, over n factorial times x minus a to the n. So for us, we're doing a Maclaurin series, a is equal to 0. So that says my function, which is e to the x, is the sum n equals 0 to infinity. Okay, the nth derivative at a is going to be the nth derivative at 0 divided by n factorial, and x minus 0 to the n is just x to the n. So now what I need to do, I need to take and I need to plug in this square right here. The formula that I came up with, let's go back, see here it is. The formula that I came up with for the nth derivative at 0 over n factorial. And that formula that we came up with, the general formula, is this. So this is the general formula. So therefore, I'm going to plug that in. And I get e to the x is the sum n equals 0 to infinity of, well, that just looks like 1 over n factorial. So I can just do x to the n over n factorial. And this right here, this Maclaurin Taylor series for f of x equal to e to the x. And just doing that, we derived it. Okay, so that is how you would derive it, a formula. Okay. Now suppose you're asked to derive the Maclaurin series for f of x equal e to the x. Now, one of the things you could do is do this table like we just did, but then the derivatives get horrible, don't they? The derivatives, we have to take the product rule, then we another product rule, then we do another product rule. Since we already know this one, we already know the series for e to the x, I'm just going to multiply. So my answer to this would be x e to the x would be x times the sum n equals 0 to infinity of x to the n over n factorial. And since x doesn't have any n's in it, I can move it inside the summation and get the sum n equals 0 to infinity of x to the n plus 1 divided by n factorial. So that's a nice slick way, okay, to find the Maclaurin series for something else from one that you already know. Okay, so instead of doing all the derivatives and everything, I can do x e to the x by just multiplying what I found for e to the x by x. Okay, any questions about that? All right, does everybody see the technique? Okay. All righty. So now we need to define or find the Taylor series. Now, this is truly a Taylor series because n is not zero, x naught is not zero. I'm doing it about n, about our, this should be a equals 2. About my a equals 2. Want to add one more column here, table, add a column to the right, and then let's move this over. Okay, so now this is a little more tricky. All right, because we start off with the function value being 1 over x, which we know is x to the minus 1. So for those people who like it like that, I'll write it as x to the minus 1. Okay. All right, so now and this is not about 0, this is going to be a 2. And then this sometimes things, you know, just work out for me, will you? Okay, and this over here, we already know that we're going to need to find the nth derivative at 2 divided by n factorial. All right, so my table's very similar. I start off needing to find the nth derivative in general. Then I will find the nth derivative at 2, and then I will take that nth derivative at 2, divide it by n factorial, and see if by the time I get down to n, I can figure out a pattern. All right, so what is the first derivative of x to the negative 1? Anybody? Hello? Anybody there?
Can you repeat the question?
What's the derivative of x to the minus 1?
Is it negative 1x?
It's okay, so it's going to be negative 1 x to the negative 2. Because we're going to subtract 1 from the exponent. So this, that was a good start. Thank you. That was a minus 1 over x squared. Okay, any questions? All right, was that Dominique that gave me that last answer?
Yes, ma'am.
Okay, you want to take this derivative, this one here, and go to give me the next one?
It's going to be negative 2x to negative 3.
Okay, the only difference is when the negative 2 comes down and hits that negative, it becomes positive.
Okay.
Gotcha. So that is now 2x to the negative 3. So I'm going to write it as positive 2 over x cubed. Now, here's the thing. If I'm trying to find a formula, I don't want to multiply anything out. Because if you multiply it out, you miss the formula. So we're just going to leave it the way it is. Okay, so the next one is going to bring down a negative 3. We're multiplying it by the 2, and we're going to get x to the negative 4. Does everybody see how I did that? So this is now negative 3 times 2 over x to the 4th. That does not look like a 4. Here we go. Okay, so now I'm going to bring the negative 4 down. So now I'm gonna get a positive 4 times 3 times 2 times x to the negative 5. Okay. So now this looks like 4 times 3 times 2 divided by x to the 5th. And you may need to do one more, so I'm gonna put a 5 here. There we go. Okay. So now I'm going to bring the 5 down. So I'm going to get negative 5 times 4 times 3 times 2 x to the negative 6. So that is negative 5 times 4 times 3 times 2 divided by x to the 6. Okay, can anybody see a formula, a pattern here? Can you start to see a pattern here? I have a 1, I have a 2 times 1, I have a 3 times 2 times 1, a 4 times 3 times 2 times 1, 5 times 4 times 3 times 2 times 1. What is that? What is that?
Is it related to a factorial?
It is a factorial. And notice this is a 5, I have 5 factorial. This is a 4, I have 4 factorial. This is a 3, I have 3 factorial. This is a 2, I have 2 factorial. And this is a 1, I have 1 factorial. So I would expect, can anybody give me what they think the pattern is down here? In terms of n. Notice this is the factorial matches the number, but the power is 1 more. So what do you think the formula is?
Would it be 6 times 5 times 4 times 3 times 2 over x to the power of 7?
Good. That's going to be the next one. So I'm going to get 6 factorial over x to the 7. And is it positive or negative?
It would be positive.
It would be positive. Okay, so now let's think about this. It clearly looks to me like I get n factorial. It clearly looks to me like in the denominator, I get n plus 1. No, I don't. I get x to the n plus 1. And it goes positive, negative, positive, negative. So all the even ones are positive, all the odd ones are negative. So I'm going to put a -1 to the end there. So that's what I can derive from my formula. Okay, so as I did this over and over and over again, remember I told you don't multiply it out, because when you multiply it out, you miss the factorial. So I clearly see that I'm going to get 6 factorial over x to the 7th. And if it was a general n, it would be n factorial over x to the n plus 1. Any questions so far? Okay. Now let's evaluate this thing at 2. So this one is 1/2. This one is -1 over 2 squared. This one is 2 over 2 cubed. Remember, don't multiply anything out. The formula will get messed up if you can't see the formula. This one's going to be -3 factorial over 2 to the 4th, +4 factorial over 2 to the 5th. This one's going to be -5 factorial over 2 to the 6. And then the formula comes out to be -1 to the n factorial over 2 to the n plus 1. All right. Now I have to come up here and divide this thing by n factorial. So I have 1/2 divided by 0 factorial. So that's just a half. I have -1 over 2 squared, and I have to divide by 1 factorial. So that's still -1 over 2 squared. Okay, so now I have 2 over 2 cubed, and it's divided by 2 factorial. So I can see that these are going to divide out and just give me 1 over, this one's supposed to be 2 squared. The next one is -3 factorial over 2 to the 4th, but I'm again dividing by 3 factorial. So the 3 factorials are going to divide out. So I'm going to get -1 over 2 to the 4th. So it looks to me like each time the factorial divides out. I get 4 factorial over 2 to the 5th, but I got to divide by 4 factorial. So again, that's going to divide out. So I get +1 over 2 to the 5th. This one's going to be -1 over 2 to the 6. And I can clearly see that all the factorials are going to divide out. And I'm going to get -1 to the n over 2 to the n plus 1. Okay, so now that I'm going to need. All righty. So we have f of x is the sum n equals 0 to infinity. The nth derivative at 2, x minus 2 to the n over n factorial. Okay, but that's what this is. This is the nth factorial the nth derivative at 2 over n factorial is that. And when we came down here, we got that formula. So that is what is going to go in here. All righty. So therefore, I get 1 over x is the sum n equal 0 to infinity. The nth derivative is -1 to the n over 2 to the n plus 1 times x minus 2 to the n. But guess what? I can make that look really cool. 1 over x is the sum n equals 0 to infinity. I can take out 1/2 and write this as x minus 2 over 2 to the n. I forgot my -1. Want it? Let's redo it. Over 2. There we go. Okay, so that is this thing right here. This is the Taylor series. It is not a Maclaurin series. For x equal to 1 over x about a equal to 2. And you can actually determine where this series converges or diverges. This is actually rather simple. This is a geometric series. If I rewrite it as the sum n equals 1 to infinity of 1/2 minus x minus 2 over 2 to the n minus 1. Here a is 1/2 and r is equal to negative x minus 2 over 2. And we know geometric series converge. So this converges. The absolute value of r less than 1. So we get the absolute value of x minus 2 over 2 is less than 1. For the absolute value of x minus 2 is less than 2. What is this number over here? This 2, what is that? What's special about that number? It has a name. Radius of convergence. And I can do the interval of convergence. That is -2 is less than x minus 2. Actually, let me simplify it first. So I have -2 is less than x minus, ooh. Come on, brain. Come on, brain. Is less than x minus 2 is less than 2. So therefore, this becomes 0. So it only converges on the interval 0 to 4. Anything beyond that, it's not going to converge. Okay, any questions about that? Tomorrow, I'm going to talk about the final, well, exam 5, the final, do a wrap up of Taylor and Maclaurin series. And then the TA will be with you on Wednesday. Thursday, you have your 5th exam. That will be in person again in the classroom where we've always gone. And then all of your information about the final exam is posted on Blackboard. All of your grades are up to date. The homework and the quizzes will close on May 2nd. And when that closes, anything that is not done will be converted to a 0. So that'll be your final score on that. And I will calculate your grade from there. The take-home exams, not the take-home, the makeup exam, please, please, please. If you really want to take a makeup exam or you want to, do that, you need to contact me. Okay, I'm looking for people to contact me. All right, so that's it for today. I will see you guys on tomorrow.
I have a question.
Yes.
Well, yeah, my homework 5.6 is not allowing me to complete it. It's saying that it's already closed.
Oh, okay. That means you must have opened it. So let me take a look at it and see. Okay. Who is that?
Chara.
Okay. All right. Yeah, I'll take a peek at it.